Hello and welcome to TypeScript object types and function types. So, when we talk about primitive types in JavaScript, so like strings and booleans and numbers and null and undefined, those are kind of easy to wrap our heads around. Um, object types and function types are where this starts getting more complicated. So if the type of A is number, that's pretty straightforward. But objects are compound types. So they have multiple primitive types inside of them. So you might have something like let B equal some property. Oops, let B. Stop it, stop it. Ultimately, it always ends up being like a primitive value. Sooner or later, it's got to be some kind of primitive. But in the meantime, it ends up getting a little bit gnarly. So a lot of times it's just a matter of like breaking it down into smaller and smaller steps. What is the type of this thing? Oh, that one's an object too. That's just making the problem smaller and smaller. But sooner or later, one of those types is going to have to be a number, a string, a boolean, null, undefined, some combination of those things, or a type literal or a function. But ultimately, all those object types will become one of those things sooner or later. And that's really the gist of it. So I want to try some exercises. Go ahead and head over to Inbox. And write a type for this object. So this is a JavaScript object that I would like you to try to write a type for. Go for it. Let's take a minute or so. All right, pencils down, send them in. All right, we're about half and half on this. So some minor syntax things that are real easy to lose. Let me copy this in. Come on, man. All right, I'm just gonna do it this way. Let's see. Okay, so this was the object. Like, a correct answer would be type. A lot of you missed that. Const is value level code. Type is type level code. Type person equals name string age number. That's probably the most straightforward way to do that. Really easy thing to screw up on this. It's like that, not like this. It doesn't use the same syntax as objects do. It's slightly different. Each one of these is more like a statement than it is like a key value pair kind of thing. It's also not equals. It's a colon, but they're not separated by commas. And then if we wanted to annotate that type on there, oops. If we wanted to annotate that type, that's what we would do. Ask me some questions about that.
Yeah, I got a question. Does person have to be capitalized after type?
It should be. There is, in JavaScript, there are two things that we capitalize, do Pascal case on. Classes, types. And classes effectively are types. So, same thing. But yeah, your types should start with a capital letter. And in fact, the only reason why they like string, Boolean, and number don't is because string, Boolean, and number in JavaScript, those are already classes. We don't use them, and if you try using them in TypeScript, you'll hate your life. Don't use them. But those are already built into JavaScript, and so they don't want to reuse those. So they came up with lowercase versions of them to serve as little placeholders. But no, by and large, types should start with capital letters.
And then I have a second question, if that's okay. On the example listed on the Seeker website, so it's got obviously like type person, and then it's got read only in front of the name and in front of age.
Totally. So if I do this, I can do person.name equals Kyle. No problem. If I do that, check it out. Oop, wrong one. If I do that, now it's mad at me because I reassigned it. That's what prevents the reassignment.
I see. Thank you.
So for whatever reason, that should never change. TypeScript will let you mutate that. That's allowed. In fact, like, yeah, if it can be any string, but it can change. If I don't want it to change, I can get some extra safety by making it read-only.
And you had said within the type to use colons, not equals. Is that for assigning those primitive values? Use a colon, not an equals?
Yeah, well, you're describing what the key is.
Right. Okay. Awesome.
Other questions so far?
If you didn't want the name or age to change, could you have used as const at the end of the braces?
Yeah, so the other way I could have done that is down here, I could have done as const. And that'll lock, that's the same thing as doing read only on all of these.
Okay.
So one of them you do when you're declaring the type, the other one you do when you're declaring the value.
Okay. And that makes a difference.
Yes. Likewise, if one of these is optional, if I get rid of age here, it gets mad at me. It goes, whoa, 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 you're missing one of the types. If that type doesn't have to be there, I can put a question mark there, and now it's not mad at me anymore.
So is that okay? Like, I know we weren't supposed to do like any types, like anything to. Okay.
Yeah.
All right.
Another one that is really easy to miss on this is that we could have also narrowed the type down to like specific values. That's allowed too. A value is also a type. That's where this starts like blowing your mind a little bit. But I could have said that the person can only be named John. Oops. That's allowed. And so then when I try to reassign that to Kyle, it goes, nice try. And like, that sounds like, well, then why the hell would you have it in the type? And the reason is because we can do things like that. Like say, it can be John, Paul, Ringo, or George. And now it won't let me put Kyle in the Beatles, but it'll let me change John to Ringo. So that's like, this is called a union type. This is something that's more specific than string, but less specific than just one value. Like, this is really common. Let's say we're modeling a car or something. Well, like something might not have an infinite number of options, but it has like more than just yes and no. So it could be like a coupe or a sedan or a truck or whatever like the type of car is. So you can make a type of all of those specific values. And now you've got the additional type safety of having it be more specific than just string. But yeah, this would have been a totally legal type for that also. Other questions so far? All right, let's try another one. So this one is going to be const student, and it'll have first name Kyle, last name of Coberly, a submission count of 1,598. Yeah. By the way, real quick side note, this is a like it's not a hack. It's part of the language, but when you're doing like long numbers like this, like we can't do commas, right? Because like that's not a valid number anymore. You can put underscores in there. JavaScript will just ignore those, so you can just break up longer numbers to make them easier to read for yourself. Not very many people know that. Like if you teach somebody at Ford that, like it'll blow their mind. That's like a lesser known JavaScript feature. And we'll have like is active true. All right, there's the type, or there's the value. inbox to catch up. All right. Prompt is out in inbox. Write a type for this object, please. Much better all around, gang. I saw, I think 2 people do, oh, here, okay. So here's the right answer. Just copy these in. Careful, careful, careful about capitalizing those. That is not the same thing, and you will be a sad camper if you try to use those. As a teaser, that's called a box. It's a wrapper that goes around the primitive that you put in. It's why you can do things like string.length, even though length is a method and string is not an object. It's a string. It is the single most complicated topic in all of JavaScript. So I would not recommend scratching at that anytime in your first 5 years as a JavaScript developer. But yeah, the primitive boxes, don't touch them. Okay, we seem to have a pretty good handle on this. So now I want to see if you can do it with a nested object. It's not actually any different doing the nesting. It's really easy to just psych yourself out about this. See if you can figure out what the type for that is. Throwing it in inbox. All right, there you go. I don't know why that has an extra curly on it. Nope. Kill it. All right, prompt is out. Write a type for this. Looking good. Looking good. Okay, we're mostly pretty solid on this. I give it about 75%. So let's talk about it. There's a couple different ways we could do this one. First part starts the same. Now, this is the part where it's a little bit different. It's not just as simple as science is a number and math is a number. Can't just do that. It is a property of the marks thing, so that has to be in it. Now, you can just say, hey, I'm going to nest it inside, and it's exactly like it was at the top level. Totally fine way to do it. In fact, you can see if I assign the type. Cool. It's not angry with me. We could also make a mark or a marks type. Come on. Put this stuff in here and say that marks is of the marks type. That's the exact same thing. I think whether you do that depends on whether you ever intend to reuse this type. If you're not gonna, and like that isn't communicating as well as this does, I would just inline it. But those are your two correct ways to do that. Ask me some questions about them.
What if I put type marks inside type students? Which is what I did in my
Oh,
example.
like that?
Mm-hmm.
Yeah, it's not valid syntax.
Okay.
So we can either make a marks type alias and then use it in here, but you can't declare a type alias inside of a type alias.
Okay, thank you.
And the type alias can be called anything we want it to be, whatever's convenient.
There you go. Other questions so far? So yeah, there's a small number of modifiers that we can make on types. Like, talked about how that makes a type optional. Optional just means that, like, doing that is the same thing as null or undefined, or string or undefined. That's the same thing as making it optional. We can say that something shouldn't change by making it read-only. We can, trying to think of another one. Those are probably the two most common that you'll see. And then, as I mentioned earlier, we can also do this at the value level. If we do that, that's saying that this will always be 75, this will always be 70, this will always be 20, this will always be the string John. Other questions about objects? This is all of it, by the way. All right, let's talk about functions. So if I make, let's say I do an add function that takes in A and B and returns A plus B. Okay, so to type those, you just annotate them. And you generally have to annotate parameters on functions. Not always, but like 90% of the time, you have to annotate them. So let's talk about the function types. Oh, actually, one more. To annotate a return type, you put it there. Now, note, you generally don't have to annotate return types. TypeScript can infer them. Now, what they can be handy for is if I don't infer it, and I accidentally do something like that, which is going to concatenate, if I annotate the return type as number, it barks at me because I didn't return the type that I said I was going to return. So like it can be useful for that. Because like otherwise it might infer the wrong type. But in this house, we don't have to return, annotate return types. Okay, so the function itself can have a type. Here's how that works. So I can say that this takes in A, which is a number, B, which is a number, and returns a number. And then instead of doing this declaration, I can say that add is that That's what a function type looks like. And now here's the cool thing. If you do that, you don't need to annotate the parameters anymore. That's one of those cases where you don't need to annotate the return type. If you've typed the function itself, and that's what a function type looks like.
So you can only type function expressions. You can't do a function declaration.
Correct. At least not that I know of. I've never heard of somebody typing a function declaration before. Yeah, if you're going to use a declaration, then just type it in place. Questions about this syntax? Okay, so the real reason that we want to know this syntax for functions is that's how we type methods on objects. So if this was actually something like const math is an object and this is a property on it, like that, I can type this object like so. I do type math is, and then put all of this stuff in here. Oh, math is already math is one of the built-in classes. That's why it won't let me do that. Math operations. Math operations. Hey, now it's typed. Now, like, this syntax is the exact same syntax we were doing a second ago. We could have some string be a string. We can have some number be a number. We can have some Boolean be a Boolean. And we can have a function that is a function type. Questions about that?
Just making sure I understand this completely. On line 2,
Yes.
the part that's in parentheses are your parameters. So
Yes.
A has a type of number, B is a type of number, and then the arrow points to the return value, which is typed as a number.
Ding, 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 ding.
Okay, and you did that so you didn't have to type it on line 8, right?
Well, you have to if you're like declaring a function type, like I am here in a method. You have to say what the return type is.
Okay, okay,
But
gotcha.
yeah, since I did that, now I don't need to type it there.
Roger. Okay, just making sure, because that syntax is a little weird, but
Yes,
I
it
get
is. It looks a lot like an arrow function, except it's all type level code. Oh, one other thing. These, like the A and the B here, they actually don't have to match up with this. I can call this face and knee. They don't have to be the same. They're really just labels to help you figure out when you're looking at the type which one is which. And they usually end up like matching whatever the actual parameters are, but that's not a requirement.
So long as face and knee were still numbers, right? That's the ticket.
Exactly. There's labels. Your turn. This one's a little bit tricky. All right. I'm going to rewrite this as a method. Just for a little added clarity. And I'm going to have it take a message also. And this will be all right, there we go. And come on, inbox. There we go. And there she blows. Write me a type for this. Well done, Parnell. This is a tricky one. All right, pencils down. Send me what you got. Nice job, Matt P. All right, let's talk about it. So first part of it, nothing too crazy. Okay, same as the first one. So here, a couple of things. Remember, this is type level code. This is value level code. Who can tell me what the difference between value level and type level code is?
Type level is just we don't know what data is going into it. We just know what the type is for each of those things. Whereas value, we're given the actual values that are there
Right.
for the
It's
variables.
Like, yeah, and it's like the implementation and stuff. So
Yeah.
it's not going to be this, because this is like value level code. That's telling the computer what to do. That's not really describing the shape of it. Also, this method shorthand that we're using here, that's also not how we declare a function type on an object. So we wouldn't say greet and then message, which is a string. We wouldn't do it like that. We'd do it like that and then annotate the return type. So a few of you got that far, but then you did the return type as string. Well, watch what happens when we do that. Huh. Not assignable to type string. Type void is not assignable to type string. What's it mean?
That greet doesn't return anything.
Doesn't return anything. If I do this, it'd be happy with that, but that's not necessary. I can just tell it that it doesn't return anything. And we're going to see that a lot in OOP code. OOP methods don't return values way more often than happens in functional code. Functional code almost always returns values, but object-oriented code, much less so.
So in mine, on what would be line 4, I
Yeah.
had accidentally not used the fat arrow here, and I used a colon to assign void. What kind of error would that have thrown?
That's just not valid syntax. So in yours, you did that, and that's just not a valid type.
Okay. So it needs the colon after greet and then that fat arrow before.
Or not. I don't know. It's not mad at me. Maybe you can do that. I wouldn't recommend it, though. I've never seen somebody write a function type that way.
Awesome. Thank you.
Other questions? All right, let's do one more. Let's see. I could have sworn there was an edge there, whatever. Return scores dot reduce. Okay, here is our object. All right, there she blows. Write me a type. Good job, Parnell. Good job, Scott. Good job, Amp. All right, pencils down. Let me see what you got. Okay, so we're about half and half on this one. So the correct answer nobody had trouble with that one. Scores, though, I saw done two different ways. The correct one is like that. Some of you put the square brackets there instead. That's not valid syntax. We're saying that the scores key will be an array of numbers. That's why the square brackets go there. And then we have a method called grade. It has a scores parameter. A couple of you did this. Well, that's not going to work because I need to reduce it. You can't reduce a number. You could reduce an array of numbers. And then we need to take a look at what this returns. Doesn't return void. Doesn't return an array of numbers. It does this little summing thing and then divides it by a number. So that will return a number. And so if I assign this type, all's good in the world. Ask me some questions about it.
All right. I don't want to brag about how much I got wrong on this problem, but I do have a question when it comes to the array numbers. I put the actual answer as like the open bracket number space line number space line number
Sure.
close bracket. I'm assuming that's just like not valid syntax whatsoever. It's not going to produce
that is. It just means something different. So if you did that is valid code, and it actually works in this scenario. See how it's like not mad at me?
Yeah.
The problem is if I try to add another score, now it's not valid. Because 4 numbers doesn't match the 3 numbers that I said were going to be here. It's because this isn't actually an array. This is called a tuple. That's saying I'm going to have an array. It will always have exactly 3 things in it, and they'll be numbers. We're not going to talk too much about tuples in this program. They have very limited use. And like you can do everything you can do with a tuple with an object, and you usually should. So if I want to say an indeterminate amount of numbers, that's what that is.
Okay. Awesome. Thank you.
For line 4, when we're setting up this method that we're going to use, is it possible that rather than saying scores and then colon number, could we just recall the type of scores that we've already assigned on line 3?
Not directly. Now, what I could do is I can make a type called scores that is equal to an array of numbers. And then I could use that for both of them. I could say scores is scores, and that's scores. That's why it's called a type alias. It's exactly like if we just typed that out. It just looks it up and like copy and pastes it in for us. That's allowed.
Very cool. Thank you.
But yeah, there's no way to do like this dot scores or something like that with the type. Other questions? Numbers.
Can you make the distinction why the last answer was void and this one is numbers? I get it that it's going to return a number after it sums everything here.
Yeah.
But why is it not? Why is it void on the previous thing when it's going to return a message?
It's because it didn't return a message. It did something like that doesn't return anything.
It's just prints it.
It just calls that log method.
Yeah.
If it did that, it would return whatever console log evaluates to, which is undefined, which isn't quite the same thing as void, but may as well be. We could also return something else after that, but yeah, that's why this returns void. Good question. What else? All right, I lied. Let's do one more. Let's do dog. Oh, no, I don't want, that would actually be a good one for a tuple. Let's see. Do them all at the same time. All the things that we can do. And let's see. Okay, so here's our dog type. This uses pretty much everything we've talked about today. Let's see how we did. Inbox prompt is live. Let's see what you got. Good job, Sean. Chris. Oh, Lord, spare me. Well done, Lauren. Well done, Scott. Well done, Parnell. Okay, pencils down. Let's talk about it. Name and breed, easy. This ailments one, a lot of you extracted that out. I like it. So the trick, if you're going to do that, is to remember to make it an array of ailments. Now, since it's an alias, it's basically like we're copy and pasting that in. So can I do something like that instead? Oh man, I really screwed that up. Can I do it that way instead? I absolutely can. Either way is totally fine. And then eat. So remember, eat is the label. Function type starts with parentheses. And eat returns a string. A couple of you freaked out about something that doesn't have parameters. It's fine. Just leave it empty. It doesn't take anything in. So just like we were writing an arrow function that doesn't take anything in, just leave that empty. And then back doesn't return anything. So we say it's void. All right, does it work? There we go. And that is Java, TypeScript, object types, and function types. What you got?
A quick question: if we don't break, so I didn't break type element out. I had it within. Do we have to put because after type string, description string, within that little nested thing, we've got the semicolons. After you put the array at the end of it, do you have to put another semicolon? Because I didn't. Do you put another semicolon there or not?
You could. I mean, they're optional in the same way that that they are in JavaScript.
Okay, it won't give us an error though.
No, but like each of those is technically like a different thing. So yeah, it would look like that.
Okay, yeah, that's how mine looked. I just didn't have a semicolon after the array.
Because yeah, that's the after the array, that's what separates all of this from the next property. But I mean, if you leave all of them off, that's fine too. I find that sometimes having the semicolons there, helps you resist the urge to put commas there. But that's exactly the kind of thing that your formatter or your linter should just be taking care of for you. Other questions?
Would we be able to just quickly go over destructure params?
Sure. So the thing that people screw up about destructured params is that it's the exact same syntax as doing it with an object. So some function, say I have a first name, last name kind of thing. So person, all right, well, what kind of type is person? So you can write this whole thing in here. It's ugly as sin, really hard to read. I'd recommend basically never doing this, like trying to define a function type in line in function parameters. It just sucks. It's so hard to read. So easy to make a syntax error on too. So we can take all of that out. And do that instead. If I'm destructuring something out in the function, none of this changes. I just do it right there. Or there. But the type is still the same. But rather than having like one person object that we're assigning this to, that I do like person dot, let's see, console log person dot first name. I can just destructure out first name instead. But it's still fundamentally the same type. I was given a whole person object on the way in. I'm just choosing to rip out that value. But the type is still the same.
When would you choose to destructure it? Like, what would prompt you to decide to destructure it?
So if I see something like, I mean, that alone, I go, wow, that person thing gets repeated a lot. So I could either say first name is person dot first name, and last name is person dot last name. And then these are just that. That's a little bit easier to read there, but I really kind of had to shit all over the rest of the body of the object to clean that up. And since I'm just yanking out a property and assigning it right away, forget it, man. Just destructure it. That's a lot cleaner.
Yeah,
And then
looks a lot better.
So in this instance, if hypothetically type person has an age property in our sum function, now that we've destructured it, we wouldn't be able to retrieve that age
You are correct.
property. Okay. Yes, I see now.
So that's the trade-off. Like you're taking those things out of the structure, and so things that are still in the structure you can't use anymore. But it's often the case that you don't actually need all of them. That's where destructuring really comes in handy. Or hell, even in this case, we were using everything that was in there, but we didn't want to have to preface everything with person.
And it's not going to break the type since it doesn't have an age now.
Well, because
like you don't have to put it.
Yeah, exactly. So I still need to give it an age. If I try to do like const Kyle equals is a person and equals first name Kyle and last name Coberly. So like that's going to insist that I have an age in there because that's part of the type. But I can call some function with Kyle and it doesn't use the age at all. But if I didn't pass in something with an age, it's not going to let me do that. Because
Okay,
I said
thank
that
you.
it takes a person type, even though I'm not using all the values from it. Other questions about any of this?
I came across a term, or I suppose it's just a tool called enum when using TypeScript in doing these object things. How often are we going to see that? No. All right.
Zero.
Awesome.
Enums are the most broken thing in TypeScript. I do not think there's a valid use case for them.
Great. Good to know.
Tuples do the exact same thing and have way less foot guns. Just ways for you to shoot yourself in the foot. Don't use enums. I think that they're in there because they're in a lot of other typed languages, and they're more commonly used in other places, but you don't need to use them in TypeScript. Anything else? Have a nice lunch.